Okay, so today we're doing Hess's law, which is going to be a way for us to calculate enthalpy change for a reaction when that reaction, we can't do it experimentally. Okay, so basically what we do is we break down an equation into multiple steps, like you can see here, and then we can manipulate those to be able to find our overall enthalpy change. So let's get started right away in the example. Our first one says, calculate the enthalpy change for the formation of carbon monoxide, which has an overall equation of solid carbon plus 1/2 O2 as a gas will give us carbon dioxide as a gas as well, if the following two reactions take place, and you can see those reactions here. Okay. Now I know you're probably wondering why we can all of a sudden have fractions as coefficients. I don't have a good enough answer for you, so just move past it. Okay, let's get going. We are finding this equation, okay? And the fact that it gives us that whole equation makes our lives a little bit easier. Our next example, they won't give us that much information. So this is what we want our end result to look like. I'm going to start with the fact that we are forming that carbon monoxide. So we have carbon monoxide as a product. If I look at my two equations that I'm working with, I have carbon monoxide there as a reactant. To get it as a product, I can flip that whole equation. So to flip it, I'm just going to write it backwards. So instead of carbon monoxide plus yield carbon dioxide, I'm going to have carbon dioxide. I'm not going to write the same matter in because I'm writing on my computer and it's already difficult enough for me. So I'm going to have my carbon dioxide that forms carbon monoxide and that 1/2 O2. Now, whatever we do to our equation, we have to do the same thing to our enthalpy change. So I did the opposite of my equation, which means I need to do the opposite of my enthalpy change. So the opposite of negative 283.0 kilojoules is going to be positive 283.0 kilojoules. So I have one step done, but now I have oxygen as a product and I don't want that. But if I look up here at my other equation, now I have oxygen as a reactant. So those two things can cancel each other out. So I'm going to write this equation down below here. So I have carbon plus oxygen, and that yields CO2. Okay, sometimes you might do the wrong thing and have to go back and circle around. So we're going to try it and hope it works out for us. And since I didn't change anything about my equation, I don't have to change my enthalpy either. So it's still negative 393.5 kilojoules. Now let's go through and cancel some stuff out. So I have a carbon dioxide over here as a product. That'll cancel out with my carbon dioxide over there as a reactant. I have 1/2 oxygen here, and I have 1 oxygen there. So that will completely cancel out. And if I take 1 minus 1/2, I'm going to be left with 1/2 oxygen over here. Now I don't see anything else in here that I can cancel out. So I'm going to write what I'm left with just to make sure I did everything right. So I have my carbon plus my oxygen. That's all that I have up here in my reactants. My products left, I have carbon monoxide, everything else canceled out. So this is what I'm left with. It matches there, so I should be good to go. Now, since I added those and added my equations to get this one, I can add these enthalpy changes to get the enthalpy change of my final equation. So 283.0 plus negative 393.5 gives me negative 0.5 kilojoules. Since we are adding, we go with the least number of decimal places for sig figs, so they both have one decimal place, my answer is one decimal place, and I should be good. Okay, so let's take it up another notch for our second example. So this one, we're calculating the enthalpy change during the formation of pentane using the given information, and we have three equations there. And like I said, this one doesn't give me what my final equation will look like, but it does tell me I'm forming pentane. And since it doesn't say I'm forming anything else, I can assume that this is my only product. So everything else in my products needs to cancel out. Okay, so let's go down here, find pentane. There it is. Again, this is a reactant I wanted as a product. So I'm going to flip that equation just like we did the last one. So we have 5 CO2 plus 6 H2O yields C5H12 plus 8 O2. And again, if I did the opposite of my equation, I have to do the opposite of my answer. So I have 3,535.6 kilojoules. So I got this as a reactant, but I need to get rid of this oxygen somehow. And if I look up here, I still have carbon dioxide as a product there, and I still have water as a product there. So I'm just going to take this one at a time, and I'm going to save my oxygen for last since I have oxygen in two places. So I'm hoping it'll work itself out, kind of like it did sometimes when we would balance equations. So I'm going to start with this one, with my carbon dioxide as a product. I have carbon dioxide, one carbon dioxide there as a product. I have 5 of them as reactants here. If I want those to cancel out, okay, I'm going to need 5 in my product. So what I can do is multiply this whole equation by 5. So then that gives me 5 carbon plus 5 oxygen and yields 5 CO2. Now for my enthalpy change, whatever I did to my reaction or my equation, I have to do to my enthalpy change. So if I multiplied my equation by 5, I need to multiply that by 5 as well. Negative 393.5 times 5 ends up being negative 1,967.5. Now I'm going to come down here and try and get rid of my oxygen, or my waters, excuse me. So I have 6 waters here, only 1 here. So I'm going to multiply that equation by 6. That is a 6. So now I have 6H2 plus 1/2 times 6 is 3O2, and that yields 6H2O. And again, whatever I did to my equation, I have to do my enthalpy change. So I'm going to multiply it by 6, negative 285.8 kilojoules times 6 gives me negative 1,714.8. Now let's go through and hope everything cancels out. So I have 5 carbon dioxide here as a reactant. I see 5 carbon dioxide there as a product. That cancels out. I have 6 waters here. I have 6 waters here as a product. That should cancel each other out. Here I have 5 oxygens. Here I have 3 oxygens, so 5 plus 3 is 8. I have 8 as a product, so that means all of those will cancel each other out. And I don't see anything else I can cancel out. So if I write what I have left, 5 carbon plus 6 hydrogens yields C5 8's 12. Okay, I can go back and check. I was supposed to form pentane. I formed pentane. And then I also want to check and make sure my equation is balanced. So I have 5 carbons over here. I have 5 carbons over here. I have 12 hydrogens there. I have 12 hydrogens there. Everything should be good, which means I can add up all of my enthalpy changes. And when you add all of those up, the enthalpy change for our reaction is going to be negative 146.7 kilojoules. Again, for sig figs, it goes by decimal places, so I should have one decimal place, and I do. So I should be good to go.